Hello and welcome to the video, which you're probably in the class already. Anyway, let's get to it. So conservation of mass and balancing equations. So I know mass is like weight, sort of. It's like how heavy things are, or something like that anyway. And then balancing, I know that's when there's like, you know, two people or weights or something, and they have to be equal, they have to balance out, something like that. Observation, mass never changes, okay? I guess conservation might be never changes, that kind of idea. Over the past several hundred years, scientists have observed millions of chemical reactions. Scientists carefully measured and weighed the reactants and products of these reactions and discovered that the mass of all the reactants always equals the mass of all the products. For example, if you react 4 grams of H2 with 32 grams of O2, you'll always make exactly 36 grams, 4 plus 32. The total mass of the reactants equals the total mass of the products. So I guess these are reactants, and these are products based on what they're saying. And it sounds like what they're saying is that whatever you start with has to equal the weight of whatever you end with. Explanation. The number of atoms never changes. By the way, this could also be moles of atoms. Not moles of chemicals, though. That's too specific. How can we explain why the total mass never changes? Good question. During a chemical reaction, atoms are rearranged, so they switch places. That's a P. They are not created or destroyed. In other words, the reactants will always contain the same number of atoms as the products. Reactants will always contain the same number of atoms as the products. To make the number of atoms equal on both sides of the equation, coefficients must be added in front of certain substances. What's a coefficient? The coefficients represent the mole ratios of chemicals in the equations. How many quantities of each substance there are. What? Still don't know what a coefficient is. So I'll put a question mark here. For example, 2H2 means 2 molecules of H2. Okay, the mole ratios, how many of each substance there are. So I'm guessing this is a coefficient. Because of this, coefficients must be distributed, multiplied in order to find out the number of atoms present. In 2H12, for example, there are 4 hydrogen atoms. 2 times 2, so I guess they did this. And 2 oxygen atoms, 2 times 1. But there's a 1 here. And then looking here, got 2H2, so that means there's 2 H2s like that, and 1 O2. There's 4 hydrogens, 2 oxygens. And over here, 2 H2Os, but 4 hydrogens, 2 oxygens. So the mass is the same because the atoms are the same, I guess. How about this one? What? So I guess if I look at the colors, it started blank, and then the red is all the work that was done. So I see there's HCl, and there's H and Cl. Okay, and there's a circle around it. There's 2 circles, so it says 2. This one, there's only 1. There's 2 OHs, I guess because of that. And then there's a line right here on the arrow. Line. I don't know why I'm labeling it. 2H2O. HHO. I guess because it's H2O. There's 2 of them. MgCl2. Okay. There's 1, 2, 3, 4 H's here total, and there's 4 H's here total. Here there's 2 Cl's, and here same 2 Cl's. 2 O's. That looks like 20. 2 O's, and then 1 Mg, 1 Mg. Wonder if this one balances out too, like that. Si, Si, 2 O's, 2 O's, 4 H's, 4 H's, 4 F's, 4 F's, and then it looks like the number of circles are the number of chemicals right there. And then there's these things. I don't know what AQ is. AQ, L. I'm guessing that's liquid because it's water, right? H2O. G, I'm guessing is gas. S, probably solid. AQ. I don't know. Weird. Huh. Well, I hope this was helpful. Bye-bye.